Hello everyone, in this video we're going to be talking about what we did in class, which was graphing quadratics in standard form, as well as going over the questions that you had for homework so that you're able to check your answers and work through it with me. Okay, so we're going to get started here. First thing we talked about in class was some general vocabulary for quadratics. This is our first section talking about quadratics. So I mentioned to students, you probably want to dedicate a single page of your notebook to like the important information about quadratics. So we talked about using like the back page of your notebook because it's really easy to find all of that information. So that if you're confused about something, you just go to the back page of your notebook and you look at your specific notes. So we're going to have so much information about quadratics. It's probably a good idea to just start a new page at the very top in big letters, write quadratics, and then fill in the information as we go throughout this like online chapter. Okay, but these are your notes and you're going to certainly take notes based on what you feel is important. So as we go through this vocabulary, if you already know some of the vocabulary, maybe you don't need to write it down because you already knew it. For instance, parabola, you probably already know is the U-shaped graph of a quadratic equation. You probably don't need to write that down, okay, but it's up to you. So here we go. Quadratic equation is just an equation that has x squared as like its highest exponent. Okay, and the parabola is the U-shaped graph that a quadratic equation makes. Sometimes they are sideways or upside down or whatever, but the idea is it's shaped like a U. The vertex is the turning point of your parabola. It's the highest or the lowest point. It's the lowest point if your parabola opens upwards. It's the highest point if your parabola opens downward. And then the axis of symmetry, that's just an imaginary vertical line through the vertex that splits the parabola in half. Okay, makes it symmetric. Throughout the year, we're going to talk about parent equations. The parent equation is always the most basic equation for a specific family of functions. So for quadratics, the most basic equation is y equals x squared. Okay, we have three different forms of a quadratic. Right now, we're focusing on just one form, standard form. Standard form is y equals ax squared plus bx plus c. Okay, and our parameters a, b, and c, those would just be numbers in the equation. Okay, so now we're going to start by like analyzing some of this information. Okay, so first things first. Specifically, number one says we're going to use the parent equation y equals x squared to answer the following. Letter A says use your graphing calculator to graph the parent equation and then draw that down below. So if I'm going to graph that, remember I go into y equals on my calculator. I'm going to type the equation in, x squared. Okay, double checking, yep, it looks good. I'm going to make sure I'm on zoom 6, which is just my like standard window view. And you can see I have a parabola whose vertex looks like it's at the origin 0, 0. So we're going to take a moment to graph that. If you're confused about what points you could use trace to kind of trace along to see like the pattern of points. And don't forget you can also use the table. And here's a good time to make sure your independent is on auto. If I want to look at the table of this, I probably want the table to automatically be generated for me. Okay, so I'm going to basically be taking these points in this table and graphing them on here. Okay, whenever I graph a parabola, I like to start with the vertex. The vertex is the middle point. On my table at least, it's at 0, 0. And then plot pairs accordingly using that symmetry. So I've got like -1, 1. I'm going to plot that at the same time as 1, 1. I've got 2, 4. I'm going to plot that at the same time as -2, 4. In my table, I can fit up to 3, 9. Wait, what? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3, 9. And -3, 9. As I draw this parabola, I'm going to be real careful about this. Just do your best to connect the dots. I'm drawing on a screen, so it's a little bit harder to draw. But notice how I extend my parabola throughout the entire graph. I put arrows on the edges indicating that the graph continues infinitely in those directions. But we can see here I've got a pretty good, pretty accurate picture of this graph here. Okay, and that's from my graphing calculator. Draw the graph below. Good, we did that. Okay. One thing I want to make note about is with a parabola, the vertex is going to be a smooth turn like that. Okay, it means something else mathematically to have a sharp turn. You're going to learn about that in future classes, but for now, just do your best to make it look like a smooth turn and not a sharp turn. Okay, letter B says now we're going to adjust this. We're going to graph y equals x squared minus 1 on the calculator, and we're going to use the calculator to find the x and y intercepts. Okay, so to do this, I'm going to need my calculator again. And now specifically, I want to go back into y equals, and I want to change the equation to be x squared minus 1. I can graph this. And then since I'm finding x and y intercepts, maybe I want to change my zoom features or my window. I don't need my y min to be all the way down at -10. Maybe I can get it to just -5 and still get a good view of this graph, or get a much better view of this graph. Yeah, see, I don't need my x's to go all the way out to -10, maybe like -7. I still want to have some space on the screen. I don't want everything crammed up on the screen. So now I'm looking at a pretty good picture of what y equals x squared minus 1 looks like. And the purpose of this is we want to learn how can we find x and y intercepts by using our calculator. Okay, so before we talked about you can use trace to kind of look at patterns on things on your graph, but you really shouldn't be using trace to answer questions, okay, to calculate something. Trace is good to like, hey, I need to see what's happening. I'm trying to figure out this pattern, but you don't really want to use trace to answer questions. Instead, to do that, we want to use this calc menu. Okay, so second trace gets us into the calc menu. First thing it wants us to find is like the y-intercept. Y-intercept is easier to find. Remember, the y-intercept is when x equals 0. So one way I could calculate that is I could pick option 1, which is value. This now has the calculator asking me to type a specific x value that I want. Well, I need to know when x is 0, so I could just type in 0, press enter. And that's going to tell me at the bottom of my screen, my y-intercept is 0, -1. That's not the only way you could have done that. Don't forget, you could also just use the table, especially if you have the table set to ask. Then when I go into the table, I could just type in the 0, and it's going to tell me the y-intercept there as well. Okay, so two different ways you can calculate a y-intercept using your calculator. For x-intercept, well, we could guess and check with the table, but that's kind of annoying. Again, trace might give you an idea. Hey, it looks like I have an x-intercept around -1. So I could use the table to check that out. Is it actually at -1? Oh, yep, I do have an x-intercept at -1, 0. But that's kind of a guess and check method, and if I get like a decimal as my x-intercept, a really annoying decimal, I'm not going to find it on the table. So I want the calculator to find an x-intercept for me. Again, I want to go to the calc menu. Option 2 is 0. 0 is another word for x-intercept. So we want to pick that. And now my calculator is going to ask me some questions. Okay, I already know this x-intercept, -1, 0. So let's have the calculator find the other x-intercept. So the first question it's asking, it says left bound question mark. And what the calculator wants you to do is it wants you can see how my cursor is sticking to the graph now. Basically, the calculator wants me to press enter somewhere that is to the left of the x-intercept I'm trying to find. So if my x-intercept is here at, like, I think +1, I want to move to the left of that a little bit, and then just press enter. Okay, kind of drew a little triangle up here, and it also is now saying right bound. And this is my calculator asking, what is the right bound, or where should I stop looking for the x-intercept? So again, there's the x-intercept, or it's close to the x-intercept. I want to go to the right of it a little bit. It's okay that it's also going up. I just need to be to the right. If you can see, my x values are increasing. It might be too small on your screen, but my x values are increasing as I move to the right. So I'm going to press enter to the right of that. So my calculator is checking between these two triangles down here, are there any x-intercepts? It's now asking me to guess. Guess just means get the cursor near the x-intercept. It doesn't even have to be that close. Guess just sometimes helps to speed up the calculations. Press enter again. And there we go. The calculator found the x-intercept for me at 1, 0. Okay, so again, anytime we're trying to calculate something from our graph, we really want to use that calc menu here. Okay, there are other ways that you can do it depending on your understanding and your skill level, but for the most part, we want to use the calc menu. And then letter C, what effect did -1 in the equation? So the equation that we were looking at in B, y equals x squared minus 1. So what effect did the -1 have in the equation compared to the parent function? Well, as I look at this graph, I can see that I used to have a y-intercept at 0, 0. I now have a y-intercept at 0, -1. So the effect was that that -1 moved the entire graph down 1 unit. Okay, so we would say something like the graph, the entire graph, but the graph shifts down 1 unit. Everything was just shifted down 1 unit. Okay, so we're starting to see patterns about how do different parts of an equation control what the graph is going to look like. Okay, so that's kind of our introduction into what we're practicing. How to graph a quadratic in standard form. Look, nobody's graphing by hand if they have to graph a quadratic equation for like a job or whatever the case is. We are learning how to graph by hand because it helps us to see patterns, see behaviors, things like that. But in the real world, you're not going to graph by hand. You're not going to follow these steps. So you don't have to like memorize these steps or anything. Just know how to do it based on these steps. But really our purpose of graphing is we're just graphing to help see patterns, to help see the behavior, so that when you enter the world then, you will notice things maybe growing quadratically. You will see that a quadratic equation models that because the behavior will look similar to what we've been doing. So our steps here, again, you don't need to memorize these. First step, you're going to find the x-coordinate of the vertex. If I can find where the vertex is, I can find the middle of the parabola. And I'm going to use the vertex formula, x equals -b divided by 2a. And then step 2, I'm just going to create a table of values. Put that vertex from step 1 in the middle of the table, and then just pick 2 numbers to the left, 2 numbers to the right. Step 3, then you complete the table of values. You plug the numbers back into the original equation to find the y values. And then step 4 is plot your points, make your graph. Okay, so we're going to see that here with some examples from our classwork. Okay, so number 1 says graph the given quadratic equation, label vertex and axis of symmetry. All right, so if I'm looking to graph this, I'm going to be following the steps from above. First thing I want to do is I want to find the vertex. Formula is -b divided by 2a. Anytime you're following a formula, always write the formula first. This helps you to learn formulas, but it also helps me or anyone else that's reading your work see exactly what's going on. Okay, so b is the number in front of x. We know this from standard form. A, b, and c are what we got from standard form. A is in front of x squared, b is in front of x, c is the number that doesn't have a variable. It's not a coefficient of a variable. So here, -b is -4, A is the number in front of x squared. Okay, the vertex is a number. It's not going to have an x in it. 2 times 1 is 2, so I've got negative 4 divided by 2. That's negative 2. Okay, this tells me that my parabola is centered at somewhere on negative 2, x equals negative 2. So I want to find where that is. So step 2 tells me to make a table of values. I don't care if you make your tables go up and down or if you make them go left and right. You just want to make a table. Here I'm plugging in negative 2 for my vertex. It's the middle of my table. I'm going to pick two numbers that are smaller than negative 2 and two numbers that are bigger than negative 2. Okay, and again, it doesn't matter what order the table is in, but do it in some kind of order, either lowest to highest or highest to lowest. And then you're going to be plugging in, so step 3 then is to plug in those values into the original equation to find the y values. Okay, so I take that original equation if I'm doing it. So I like to start with the vertex, it's the middle point. I'm plugging in a negative 2 and squaring it. I'm going to multiply negative 2 times 4, and I'm going to be adding 2. Now, all of this I'm showing in purple. When you have a table of values, you do not need to show this work. You can do it mentally. You can have the calculator calculate the table for you. The purpose here is we want to find our values. And as long as you have an equation, I don't need to see how you calculated the table of values. So 4 minus 8 is negative 4 plus 2. That's going to get me negative 2. So the only thing I would need to see is the negative 2, the final answer. And you would do the same thing for negative 3, negative 1, negative 4, and 0. And notice how I talked about those. Remember, a parabola is symmetric. So if whatever I find for negative 1, when I plug negative 1 into this equation, maybe you're thinking about it mentally. Negative 1 squared is 1. 4 times negative 1 is negative 4 plus 2. So 1 minus 4 is negative 3. Negative 3 plus 2 is negative 1. I'm going to get the same value for negative 3 because parabolas are symmetric. If I plug in negative 3 squared is 9. 4 times negative 3 is negative 12. So I'm going to have 9 minus 12, that's negative 3, plus 2, that's negative 1. So one kind of shortcut for calculating your table is do the easy numbers. Negative 4 and 0 are going to have the same y value. So if I just plug in the 0, the easy number, 0 squared is 0, 4 times 0 is 0, 0 plus 2 is 2. As long as I've set up everything correctly and done everything correctly, I'm going to have the same y value for negative 4 as well. Okay, so that was step 3, which is calculating my y values. Step 4 is to then make the graph. Okay, I don't need my calculator here. So for this, I like to again plot from the vertex, so I'm going to start at negative 2, negative 2, negative 2. And then I'm going to plot negative 3, negative 1, and negative 1, negative 1. And then I'm going to plot 0, 2, and negative 4, 2. Now we talked earlier about making sure we have complete graphs. If you're good enough, you can draw this whole parabola, but a complete graph means we need to extend the whole way up the graph. So to do that, it might help me to fill in another number for my table of values. Okay, you need to make a table that has at minimum like those 5 points, your vertex, and then the 2 above, 2 below. But if you need additional points, that's fine too. It's going to make your graph more accurate. So if I square 1, 1 squared is 1. 4 times 1 is 4. 1 plus 4 is 5 plus 2 is 7. So I'm going to have these other 2 points here as well. Okay, 1, 7 and negative 5, 7. But that's definitely enough points now that I can accurately draw this graph. Notice how I'm drawing. I don't start at the vertex. I'm going to draw this whole thing in one single motion if I can. And I'm really trying to make sure that I keep that smooth turn at the bottom there. The vertex needs to look like that smooth turn, not a sharp V looking thing. But you're drawing this graph by hand. A graph drawn by hand doesn't need to be perfect. It just needs to be accurate. Just need to do the second part of the problem, which is label vertex and axis of symmetry. Whenever you label something, we're going to label with the name and the location, -2, -2. The axis of symmetry we talked about at the vocabulary. It's the imaginary line that goes straight through the vertex. It's vertical. So this graph is a picture of all of the solutions of this equation. Points on the axis of symmetry are not solutions. So we use a dashed line to indicate that this part isn't actually part of the solutions. It's like this imaginary line. Okay, it shows us the symmetry of the parabola. And again, we're going to label it. Don't label it AOS. Nobody knows what AOS is. It's okay if you abbreviate symmetry as SYM. I think people would get that. Name and location. Its name is the axis of symmetry. Its location is x equals -2. Okay, so number one is an example showing off basically how to graph, our steps for graphing, as well as what the vertex looks like from the vocabulary, as well as what the axis of symmetry looks like from the vocabulary. You do not need to label a graph unless directions ask you to label something. Okay, moving on, number two. Graph the previous equation on your graphing calculator. Use your calculator to determine the minimum and maximum of the equation. Okay, and then it says the maximum right here is the highest point on the graph, and the minimum is the lowest point on the graph. So to do this, I'm going to want my calculator again to calculate the minimum and the maximum. So first thing I want to do is type in the equation x squared plus 4x plus 2. Then I'm going to graph this. This is actually a pretty good view of this graph here. Okay, so I don't really need to change the window settings or anything like that. So the maximum. Well, if the maximum is the highest point, this graph has no max. Because no matter what point I give you, hey, this point up here looks like it's the maximum. Remember that it keeps going on forever. There's always a point higher. Okay, so no matter what point I give you, you can give me something higher. So this graph has no maximum. For minimum, remember the vertex is the highest or lowest point. So we already know what the minimum's going to be. It's the vertex. But we want to see that from the calculator. We want to know, how do I calculate the minimum using my calculator? Okay, so to do that, again, I'm calculating something. I go to the calc menu. And I'm going to make this bigger again. I'm going to pick option 3, minimum. So here I want option 3, minimum. I can either press the 3 or cursor down to it. And it's doing the same thing it did before for x-intercept. It wants to know the left bound. So I know the minimum is somewhere in here. So I need to move the cursor somewhere to the left of that. And you can kind of watch the values to see, okay, I'm to the left of that. I press enter. Right bound means I go to the right of where I think the minimum is. I'm going to go a little bit farther. The calculator can handle it. And then for guess, you put the cursor near where the minimum is. Press enter. And you can see, if you see these numbers here, -2.00000001, this is just round off error from the calculator. The calculator is trying to calculate with guess and check where it thinks the minimum is. Okay, it's checking all the values in between where you picked as your left bound and right bound. So we have to make sure we understand this is just calculator error. Okay, the minimum is actually at -2, not at -2.00000001. Okay, and that's from our own understanding. Oh, the minimum occurs at the vertex. But the calculator is there to kind of help out if we are stuck on something, if we're not sure what's happening. We always talk about showing work on problems. Here I already have the graph in number 1, so I don't think I would need any additional work for number 2. Maybe you leave a little note, see graph at number 1 for your work, but really there's my final answer. And technically my final answer should always be after the work. So I should have had that note saying see the graph at number 1 first. Number 3, we're going to find the domain and range. Same thing, we're going to see the graph. We don't need to redraw the graph. I've already drawn the graph. So my domain, remember, is my possible x values. The x values I could plug into this equation. The values for x that are on this graph. So I can see my parabola goes up and to the left forever in this direction here. And it's going up and to the right forever in that direction there. Okay, so that really means that my x's could be any number. Okay, there's no limit to what my x's could be. So different ways I can write that. I could write it as an inequality. Negative infinity is less than x, and x is less than infinity. This indicates to me that x is anything between negative infinity and positive infinity. You'll notice we don't use or equal to with infinity because infinity is not a number that we can equal. It's just an idea that numbers go on forever. Okay, I can tell you count to 10 and there's a stopping point, 10. I can't tell you to count to infinity because there's no stopping point. So infinity will always have a less than sign, never less than or equal to with it. So you could write domain as an inequality. You also could write domain using other symbols. This says x exists in the set of all real numbers. Okay, so that E there is like the letter C. You draw like an extra little loop. And then real numbers, it's like the paragraph mark, but then you draw an extra, it's just an R with an extra like back to it. Okay, 2 different ways that you could write domain. You could also write the domain as a sentence, but generally in math class, we don't want to write sentences. We've invented symbols to make that work easier. So you kind of want to use the symbols. For range, I'm going back to the graph. Remember, range is how far up and down the graph goes. This graph goes up and up and up forever. It goes down all the way here and stops at -2. Okay, so my range then, range is y values. Y is greater than or equal to -2 is one way you could write it. Or if you prefer the like longer and inequality, -2 is less than or equal to y. So, or equal to, it does actually reach -2. It goes down to -2. And y is less than 2. Either answer, whichever one you prefer, works here. Okay, so for the rest of these, we're just going to practice making graphs. Again, we're making these graphs by hand. We're practicing graphing by hand. We want to know what things look like, how do they behave, and what patterns can we see, things like that. So I don't need my calculator for now. Okay, on number 4, again, first thing I want to do is I'm going to find my vertex. So here I'm showing you the work that you would show on any problem. If this is like a graded assignment or a homework assignment, anytime you were doing number 4, this is the work you'd be showing. So I first write the vertex formula. I fill in my numbers. B is -6, so I'm going to be real careful with this. A is -3. So it's 6 divided by negative 6, which is negative 1. I put negative 1 in the middle of the table. I find two numbers smaller than negative 1 and two numbers bigger than negative 1. From here, I'm going to want to plug in those numbers to the original equation. Again, I like to start with the vertex. It's the middle. So I got negative 3 times negative 1 squared minus 6 times negative 1 plus 4. This one's more difficult. I'm going to take my time with it a little bit more. But what I'm doing in purple, maybe you're doing on scrap work. Maybe you're typing it directly into the calculator. Whatever. I think, though, if we're trying to practice by hand, we really shouldn't touch the calculator unless a question specifically says, do this on the calculator. You really have negative 3 plus 6 plus 4. Negative 3 plus 6 is 3. 3 plus 4 is 7. So I'm going to have that point negative 1, 7. Remember 0 and negative 2, they're both one space away from the vertex. They're going to have the same number, the same y value. So it's easiest to plug in 0. 0 squared is 0 times 3 minus 6 times 0. That's all 0 plus 4. Okay, and then either 1 or negative 3. I've got to plug that in. Probably going to be easier to plug in a 1 than a negative 3. So I can take a moment and plug in 1. And again, you could do this mentally. You don't have to show this. What I'm doing in purple is like optional. That's me talking to you. So negative 3 times 1 squared minus 6 times 1 plus 4. 1 squared is 1. Negative 3 times 1 is negative 3 minus 6 plus 4. Negative 3 minus 6 is negative 9. Negative 9 plus 4 is negative 5. I wonder if there's any patterns going on in that table there. Interesting. Next. Spoiler, there is. If you don't see a pattern, maybe try to find more values on that table. But anyway, we don't need to find that pattern right now. So here I've got to set up my graph. You can see I have like a piece of graph paper off to the side. I don't have the axes pre-set up for me. And what I'm trying to do here is I'm looking at my values. I go from negative 5 to 7. So it looks like I can scale by 1 as long as I call the bottom negative 5. I can count by 1s. Generally, it's easiest to graph whenever we count by 1s because you're not going to have as many mistakes. Negative 1, negative 2, negative 3, negative 4, negative 5, yep. So I'm drawing in my x-axis here. My y-axis can just be kind of in the middle somewhere. My y-axis there. And then I'm going to start plotting those points. So I have negative 1, 7. It's all the way at the top. Negative 2, 4. I'm going to pair that off with its friend 0, 4. Hey, there's my y-intercept. And then I have 1, negative 5. That's all the way down at the bottom. And negative 3, negative 5. I'm then going to do my best to draw, a smooth parabola through this, especially at the turning point, the vertex. And I'm going to put arrows on the end. This problem didn't ask for me to label anything, so I'd be finished there. My graph is the final answer. You don't need to circle the graph because I gave you the space for that final answer. So throughout the year, anytime I give you a space for your final answer, you just leave your answer on that space. So like a graph, or if I give you a blank to write like domain and range on. Okay, that's it though. That's our practice graphing. Okay, so your homework then is to just continue that process, practice graphing for each one of these. Okay, so I'm going to run through these rather quickly. You can, of course, rewind, fast forward, go through, skip around, look at the problems that you need to watch to make sure you understand. But there are a few catches. There are a few catches in here, so you do want to make sure you do all the problems. Don't just do one problem and say, yep, I got it. Unless you are really, really an expert. So we have another vertex happening at -1. This is the same as the last problem. So from here, I make my table. Put -1 in the middle. Calculate my y values. Maybe I can do this mentally, maybe not, whatever. Where's my purple? Okay, so I'm thinking -1 squared is +1. Maybe I'm just doing it right above the equation as well. 2 times -1 is -2. So I have 1 minus 2, that's -1, plus 1 is 0. So I'm going to have -1, 0. Then I have to decide, do I want to plug in 0? Do I want to plug in -2? Definitely going to be easier to plug in 0. 0 squared is 0. 2 times 0 is 0. 0 plus 1 is 1. 0 and -2 are both one space away from the vertex. They're both going to be 1. And then I can either plug in -3 or 1. Probably going to be easier to plug in 1. Again, I can do that mentally. 1 squared is 1. 2 times 1 is 2. So 1 plus 2 plus 1 is 4. That's 4. That's 4. Hey, I wonder if there's any patterns happening in that table too. Interesting. Anyway, continuing on. I'm then just plotting my points. -1, 0. 2, 1. Or sorry, -2, 1, 0, 1. And then 1, 4. Remember, a complete graph, we don't just draw a little snippet of a parabola. Complete graph means we extend our parabola all the way up through the remainder of the graph. And if you're going to extend freehand, just be careful. Make sure you're drawing it accurately. If you are good enough that you can draw an accurate parabola by hand, go for it. If you can't draw it accurately by hand, include additional numbers on the table of values. So I know 2 is going to be the same thing as -4. So I can use that to kind of help myself. Let's see, how good am I at drawing a parabola freehand? If I plugged in 2, 2 squared is 4. 2 times 2 is 4. So I have 4 plus 4 plus 1. That would have been 9. So let's see how close to 2, 9 did I actually draw. 2, 9. Oh, look at that. It's like exactly on. And then -4, 9. Yeah. So here when I'm checking work from students, I always say your graph doesn't have to be perfect. It just needs to be accurate. So for me, you saw how I freehanded that. My graph being accurate means that generally my points are within one block of where they're supposed to be. Okay, you can kind of see, yeah, I messed up here a little bit. And over here, I kind of messed up a little bit. But for the most part, each one of my points is within one block of where it's supposed to be on the graph. So I would say that's accurate. It's not perfect, but it's accurate. One last thing I need to do, the directions tell me to label vertex and axis of symmetry. Remember, the axis of symmetry is a vertical line through the vertex. It's an imaginary line, that's why we draw a dashed line. So I've got a vertex here, and just label someplace where you have space, where things aren't running together. Label with name and location. And my axis of symmetry is an equation because it's a line, x equals -1. Technically, the axis of symmetry would also have arrows on it. It is a line. It continues on forever. Typically, I don't draw arrows on it just because it gets real busy on the graph to have arrows all over it. That's up to you, your preference. Okay, but that's it there. I've graphed this equation now, and I've labeled vertex and axis of symmetry. Moving on, next I've got g of x here. Okay, g of x, remember, means the same thing as y. But the nice thing about calling this g of x is now I can talk about that equation. Guess I could have mentioned that on 5, f of x. Anyway, same thing. Starting by finding the vertex, negative b divided by 2a. Negative b divided by 2a. Whoops. 6 divided by oh no, this one's going to be annoying. I have a vertex that's a fraction. So for my table of values, I'm putting the vertex in the middle of my table. Remember, I need to pick numbers that are smaller and bigger. 2 numbers smaller, 2 numbers bigger. So negative 3/2, that's really negative 1 1/2. So negative 2, whoops, let's space that out a little. Negative 2, negative 3, negative 1, 0. My goal is I want to keep this equally spaced out as much as possible so that I can cheat, not cheat, but so I can take shortcuts when I find the y values. So negative 2 is halfway away from the vertex. It's half of a point. And negative 1 is halfway away from negative 1.5. Okay, and then 0 and negative 3. These are all equidistant. That's what we're talking about here. They're equidistant. Equally distant from the vertex means that they'll follow that pattern. It's going to be easier then to find the y values. So negative 3/2. Probably not going to do this in my head. I could probably use my calculator, but I'm going to try it without the calculator, see how it goes. And I'll erase this then. It's not going to stay on top of the graph. So this is really tedious. Negative 3/2 squared is 9/4. Over here, I'm going to have 6 times 3 is 18/2, positive 18/2. Negative times a negative is positive, plus 3. We're going to be real careful here. You should be able to do this by hand. Okay, so here you can see I'm not using my calculator. I'm doing this by hand. I want to get that practice so that things are okay for me. Okay, negative 2 and 4, those can cross simplify to 2 and 1. So now it's negative 9/2 plus 18/2 plus 3. Well, 3 is the same thing as 6/2. I might as well make a common denominator there. This would then be 9/2 plus 6/2, which is 15/2. So I'm going to write 15/2, but I'm thinking in my head that's 7.5. Okay, then, okay, so I can erase all that. Actually, I'll pause while I erase. Okay, I got that all erased here. So now I'm plugging in like negative 1, same deal. I'm plugging that in. I can think about this mentally or not. Negative 1 is going to be a lot easier to plug in because I'm not dealing, the fraction was the annoying part of the first one. Negative 1 squared is 1, so I've got negative 2 plus 6 plus 3. Negative 2 plus 6 is 4. 4 plus 3 is 7. I know since I equally spaced my numbers from the vertex, negative 2 is going to give me the same answer as negative 1 did. You can do the same thing for 0. 0 squared is 0 times negative 2 minus 6 times 0. All of that just gets me 3. And that's 3 there. Okay, so I've got my table. I'm ready to make my graph. And again, here I'm thinking this. I wouldn't write this down, but I'm thinking this is really 7.5. And this is really negative 1.5. It's just going to help me to draw my points. So negative 1.5 comma 7.5. It's going to be like right there. Then I've got the 2 points near it, -2 and -1. And then -3. And 0. Here I'm feeling like, you know what? I need to have another point. I can't draw this accurately. So I'm going to do that real fast. -2 times 1 squared is 1, minus 6 times 1 plus 3. So -2 minus 6 plus 3. -8 plus 3 is -5. So that's just going to help me out in graphing the rest of my parabola. Okay, our goal is accurate graph, not perfect. So I go through. Okay. Drawing that parabola as best I can. And hopefully you're thinking about, hey, look at this. Wow, this one's upside down. What about the original equation makes this upside down? Those are the patterns you're looking for as you keep on graphing. Maybe you already know that. Maybe you learned it before. Maybe not. So what's different about the original equation? In 5, that makes the parabola open upwards. That in 6 makes the parabola open downward. Okay, moving on, number 7. Here in number 7, I have a fraction that I'm going to have to deal with as I find the vertex. So we're just going to see an example. Oops. Negative times -3, or the opposite of -3 is +3. The bottom would be 4/3. Remember, division means the same thing as multiply by the reciprocal. So instead of doing 3 divided by 4/3, we could do 3 times 3/4. Which gets me 9/4. Okay, so this table is going to be really, really annoying because the vertex is not a nice integer. I've got 9/4 sitting in the middle of my table. Okay, and remember 9/4 is the same thing as 2 1/4. So as I make this table, I'm probably not going to have x values that are equidistant from the vertex. What I mean by that is a number that's slightly bigger than 2 1/4 is 3. That's 3/4 of the way away from the vertex. It's 3/4 of the way away. From 2 1/4 to 3 is 3/4. This other point up here, if I use 2, 2 is smaller than 1/4, but you can see how that's closer to the vertex. Okay, that's only 1/4 away from the vertex. So 2 and 3 are not going to share the same y value. So the reason that I have this problem on here is to recognize, don't just blindly copy the numbers from one to the other. They have to be equidistant. 3 is farther away from the 9/4 than 2 is. So they are not going to have the same values. Now you could, if you wanted to, you could use 3 1/4 and 2 1/4 and then 1 1/4. But then you're going to also be plugging in decimals or fractions or whatever in for your y values. So you really have a choice here of either using fractions for x and then being able to keep it equidistant so that you can just copy your y values, or use easy numbers for x, and then you're going to have to actually calculate all 5 of the numbers. Okay, because none of these numbers are equidistant from 9/4 from each other. Okay, so if I'm going to do that, so I guess on this one we can talk about how could I use the calculator to speed up the table of values. This is, again, though, it kind of defeats the purpose of, if we're graphing by hand, why are we using the calculator? But we can talk about using the table on the calculator to help us find a table of values. So to do that, I first want to type in the original equation. Division is just, a fraction is just division. Okay, so you don't need, where's the division bar or the fraction bar? There's no such thing. It's just the division key. So 2/3 x squared minus 3x plus 6. I don't need to graph this. I'm curious about the table, so I'm just going to go right into the table. The nice thing is I'm still on ask for my independent variable. So this lets me, when I'm in the table, just type in the exact numbers I have on my table. 1, 2, 9/4, 3, and 4. Okay, and we can see on here then that you can see I don't have that matching numbers or whatever because they weren't equidistant. So what I have, 3, 3 is the only number that's nice, easy to work with. I've got, what, 4 2/3 on here. I've got, what is that, 2 2/3. So 2 2/3. And here I'm just using mixed numbers, whatever. It's not a big deal because this is just helping me to make my graph. My vertex, 2 5/8. Like what? Nobody's going to be able to tell that I graphed 2 5/8 exactly. Okay, I'm just going to try to get it close. And then 3 2/3. But 2 5/8 is real close to 2.5. Okay, so as I'm making this graph, plotting my points here. So I've got 2 1/4, and then I've got 2 5/8. 2 1/4, 2 5/8 might be like right there. And then I've got 3 3. 3 3 is an easy one to do. I've got 2 2/3. I've got 1, 3 2/3. And I've got 4, 4 2/3. So this one's really, really messy. I'm doing my best here. Drawing straight through those points. Trying to make it symmetric, trying to make it smooth turns throughout. Okay, and I would have a y-intercept here of 0, 6. Oh wow, and that's pretty much exactly where my line crosses, or my parabola crosses at 0, 6. Okay, so I know the y-intercept is 0, 6. Looks like I hit that pretty well. Okay, so again, maybe my graph isn't perfect, but it's pretty accurate. Okay, good enough. All right. I think we got 2 more, 8 and 9. Yep, 8. Same thing. Gonna find my vertex. Oh wait, was there anything else I had to do there? Oh, I didn't think about the other one either. Domain and range. I bet I didn't do max and min. Oh, that's really annoying. Okay, so what is the maximum and minimum of g of x? We're gonna go back here. So the max is the highest point on my graph that's occurring at the vertex. So -3/2, 15/2. The minimum here, there's no minimum. Okay, this graph continues to go down forever. So hopefully you weren't screaming at me too. No, you forgot to do that part of the directions. I got it now. Sorry about that. This one here, what is the domain and range of h of x? Domain is what x can be. Parabolas go to the left and to the right forever. So x can be any real number. -infinity is less than x, and x is less than infinity. My range, a little bit difficult here on this one. I've got this 2 5/8. Probably don't want to use a mixed number. For the most part, you don't use mixed numbers anymore. There's not really a lot of uses for mixed numbers. So I probably should convert that out of being a mixed number. So to do that, 2 5/8 would be 2 times 8 is 16, plus 5 is 21. So 21/8. My vertex goes all the way down to 21/8. and it goes up forever. So here I would say something like y is greater than or equal to 21/8. It's all the numbers bigger than that. So there's my domain and range. Okay. Now in number 8, and this is really what caught my attention here, number 8 doesn't have any other directions, it's just telling me to graph. Okay, so yeah, that was fine. So as I graph this here again, finding my vertex, b here is 1, so -1, divided by 2 times a half. 2 times a half is 1. So again, I have a vertex at -1, excuse me. And here, I guess the purpose is, obviously, we're multiplying by that 1/2. I'm going to have like fractions as I'm calculating my table of values. Also pretty annoying. Maybe it's one you use on the calculator, whatever. So here I'm going to have 1/2 times -1 squared plus -1 minus 3. -1 squared is 1, so I've got 1/2 minus 1 would be the same thing as 2/2. And then minus 3 would be the same thing as 6/2. I'm finding common denominators as I go. 1/2 minus 2/2, that would be -1/2 minus 6/2. So that would be -7/2. The nice thing about this problem is that my x values are all equidistant from the vertex. So I can kind of pair off the points. Meaning my answer for 0 is going to be the same as my answer for -2 because those are both one space from the vertex. So if I plug in 0, I'm going to get -3. If I plug in 2, or -2, I'm going to get -3. And then need to plug in 1. This is going to be slightly different than the vertex. So 1/2 times 1 squared is 1 plus 1 minus 3. So I've got 1/2 plus 2/2 minus 6/2. That's 3/2 minus 6/2 is -3/2. So then we plot these points. So I've got -1, -1, -3.5. We've got 0, -3. We've got -2, -3. And then I have 1, -1.5. And -3, -1.5. Okay, maybe this is difficult to draw. Maybe I add on an additional number on my table of values. So I got 2 squared, which is 4. So 1/2 times 4 plus 2 minus 3. 2 plus 2 minus 3. 2 plus 2 is 4, minus 3 is 1. So I'll have like 2, 1. And again, maybe that's still too slow. Maybe you need to add on additional points. From here, I'm okay. I think I can draw this. So I'm just doing my best. To draw my parabola through those points. And of course, we extend all the way to the edge of the graph. So if you make a graph that's big like this, goes 10 in each direction, you're going to have to extend the whole way. Okay, I think we got one more. Yep. So in our last question here, now this is asking us to think about this. We're going to analyze situations. A little bit of a challenge, not something you've directly seen before. It says the points 2, 3, and -4, 3 lie on the graph of a quadratic function. Okay, so I know those are 2 points on my graph. Is this enough information to determine the axis of symmetry? If yes, find it. If no, explain why not. Okay, this is enough information to find the axis of symmetry. The axis of symmetry is always the middle of the parabola. So if I have a point at 2, 3, that's going to be like right there, and another point at -4, 3, well, my axis of symmetry is going to be somewhere in between there. It's going to be halfway in between there. So one way that I could find where is the axis of symmetry is to just take the average of the two x values. Because that's going to find the middle for me. I have two values. If I add them up and divide by 2, that's going to tell me where the middle is, where the axis of symmetry is. So 2 minus 4 is -2. We got another one. X is -1. So my axis of symmetry is going to occur at x equals -1. Okay, and again, I did that because I know these 2 points, they're on the same y value. They both have 3's. So I know that they are both like here on the graph. So that's kind of part of my parabola. I don't know anything more about the parabola except those 2 points. Is this enough information to determine the vertex? If yes, find it. If no, explain why not. I know part of the vertex. It's not enough information. I know the vertex is going to be at -1 something, but I can't calculate the y value. Cannot find y. Okay, I'm going to need the original equation. I'm going to need more information to know where y is. So again, if I look at that graph, I have those 2 points. Maybe the vertex is up here and it goes down like this. I have those 2 points. Maybe the vertex is down below and it goes like this. We aren't sure. So we can find the axis of symmetry, but that's it. We can't find the vertex if all I have are these 2 points here. Okay, so that's it. That's all our information about graphing quadratics from standard form.